Welcome to the deep dive. If you were online back in, 2018, you could not escape it. This viral thing that just, it caused real arguments, genuine confusion all over the world.
Oh, absolutely.
It was like a question of objective reality itself, but, boiled down into a 4-second audio clip. Do you hear Yanny or do you hear Laurel?
It was magnificent chaos, really. I
Huh.
mean, most viral things are about opinions, right?
Yeah.
But this was different. This was about fundamental sensory input.
Exactly.
People were hearing two words that sound, phonetically nothing alike.
Yeah.
And yet they were completely convinced their version was the only correct one. It became this instant case study in human perception.
It really did. Okay, let's unpack this. We aren't talking about a simple majority here. The Twitter polls that started it all, they showed a split that was almost perfect.
Unbelievably close.
47% of people heard Yanny, while 53% heard Laurel. When something divides us that cleanly, it tells you the answer isn't just in the clip itself. It has to be in us, in the listener.
That's the key. Our mission in this deep dive is to, synthesize the science, the physics, the biology,
Yeah.
the little cognitive tricks that explain why your experience could be so different from the person sitting right next to you.
Right.
We're using this kind of bizarre internet moment to explore some really cool concepts, like frequency, selective attention, and how our expectations literally shape what we hear.
And expectations, that seems like the right place to start. That 4-7-43 split, it probably wouldn't have happened if the context wasn't already set, which brings us to cognitive priming.
Exactly. When the audio first went viral, it was always presented with the question, do you hear Yanny or Laurel? Now just think about what would happen if you played that same clip for someone who had no idea about the debate. You give them no options at all.
They probably just hear a weird noise.
Our sources suggest they might hear a garbled sound, maybe something like Yarny or Lori, or, maybe neither of the two famous options.
So, just by being told the potential answers, we're forcing our brains into a really restrictive choice. We're not hearing the sound raw anymore. We're hearing it through a filter of suggestion.
You are activating a cognitive expectation. Priming, in this context, it just means that the information you get beforehand, seeing those two words, it prepares your brain. It starts searching its memory for phonetic data that matches only those two options. Your brain is just being efficient. It's using that hint to solve an ambiguous puzzle.
That's fascinating. It sort of implies that if we'd been primed with, I don't know, banana or tomato, we wouldn't be having this conversation at all.
Absolutely. The phonetic closeness of Yanny and Laurel, that only matters once those words have been introduced. The priming just makes sure your brain ignores all the other possibilities and it locks onto the only two paths it's been given.
It's a powerful demonstration of how context really preconditions what we perceive.
It really is.
Okay, so our expectations narrow the field. But Yanny and Laurel are still pretty different phonetically. So even with priming, it seems like we shouldn't have this much trouble telling them apart. The sound waves themselves must have some kind of ambiguity baked in.
And that's the next layer.
Yeah.
If we look at the sound waves that make up speech, we can actually see them. Brad Story, he's a professor of speech, language, and hearing. He analyzed the acoustics of the original recording.
And what did he find?
What he found was pretty surprising. Visually, the sound waves for Yanny and Laurel, they share a lot more overlap than you'd ever expect.
How does that work? Are the waveforms just messy?
It's not just the shape. So speech sounds are made of these frequency bands called formants. You can think of formants as the distinct stripes you see on a sound graph. They're bands of energy our vocal cords produce.
Okay.
Story's research showed that the formants, which are the critical bits of sound our brain uses to tell one vowel from another, in Yanny and Laurel are surprisingly close. They occupy a very similar acoustic space.
So if the data looks similar, and it's a low-quality recording to begin with, it gives the brain an excuse to misinterpret it, or to pick one data stream over the other.
Precisely. That visual similarity provides the acoustic ambiguity. It's what's necessary for the brain to select one path. And that confusion gets immediately amplified by the most basic variable of all, your listening environment.
Right, the listening device. Everyone was listening on their phone speakers or their old earbuds or cheap laptop speakers.
And this is so much more critical than people realize. Different devices are engineered to prioritize different frequencies. For instance, cheap phone speakers. They're generally terrible at reproducing the very high-end sounds, but they often boost the mid-range.
Which is where human speech usually sits, right, to make calls clearer.
Exactly, so you can hear dialogue in videos or on phone calls clearly. So if that phone speaker is deliberately crushing the high end to make the mid-range clearer, which one of our two words is likely to just vanish?
The word Yanny, I'm guessing.
Yanny, which we know relies on those higher frequencies. It often gets lost or muted by standard small speakers. The word Laurel, which uses lower, more robust frequency parts, is much more likely to stay dominant. So just listening on a lo-fi device already pushes you toward Laurel.
But then you have the really baffling situation. You put two people in the same room with the same expensive headphones, controlling for all of that, and still one hears Yanny and the other hears a Laurel. If it's not the external environment, what's the major biological difference left?
Now we have to go completely inward, past the acoustics, past the device, and into the biological receiver itself. The sources really emphasize the physical capacity of the listener's ear, which is heavily, heavily influenced by age.
That seems like a really powerful explanation. How does aging actually affect our ability to hear this specific clip?
It's all about frequency detection. The Yanny parts of the sound are all in the high frequency range. The Laurel parts are mostly in the lower frequencies. A really well-documented physiological change in humans is age-related hearing loss, which almost always affects our perception of higher frequencies first.
Wait, so you're saying a person's age could be enough to definitively change their perception of objective sound data?
It's not 100% definitive for everyone, but it's a huge piece of the puzzle. The tiny little sensory cells inside the cochlea, the hair-like things that detect sound waves, they wear down over time. And the ones responsible for high-pitched sounds go first.
So if your ears have a diminished capacity in that higher range, your brain just never gets the full data stream it needs to build the word Yanny.
Exactly. It provides a concrete physical reason for why two people listening to the same sound wave might receive different raw data. The high frequencies needed for Yanny get filtered out by the older ear, and that leaves the brain to interpret only what's left, which is the lower frequency Laurel.
And we don't have to just speculate about this. The internet gave us the perfect controlled experiment through direct pitch manipulation.
This was the clincher. A Twitter user at PHEW took the original clip and just manipulated the pitch digitally. It bypasses all the issues of ear age or speaker quality, and it proved that frequency is the real driver here.
What were the findings from that pitch shift? What happened?
They found that when the pitch of the original was brought down by about 30%, every single listener heard Yanny universally. And conversely, when they brought the pitch up by 30%, everyone heard Laurel.
That is incredible. So it proves that the data for both words is actually there in the original recording, just on different frequencies.
It confirms the ambiguity is baked into the data. Your perception isn't wrong, it's just that your physical hardware determines which data stream you can access. But even after the ear gathers the data, we still have one final powerful filter: the brain itself.
So we move from the external world and the biological receiver to the ultimate decoder. The brain is getting all this stimulus all the time. How does it deal with this conflicting Yanny-Laurel input?
This is where selective attention comes into play. The brain isn't a passive recording device, it's an active interpreter. It uses these very precise neurological pathways to decide which sensory input to prioritize and which to just discard as background noise. It has to make a choice about which frequency band is the real signal.
It's the ultimate executive decision maker. I mean, if it paid equal attention to every sound, we'd be instantly overwhelmed.
We would be paralyzed. The sources use a great analogy for this, the cocktail party effect.
Right.
Imagine you're at a loud, busy party. You can easily focus on your friend speaking right next to you, and you filter out everything else. But if someone across the room shouts your name or says something that triggers a response, your attention just instantly pops over to that distant conversation.
That's a perfect illustration, yeah. But in that case, my name is the trigger. What's the subconscious trigger in the Yanny-Laurel clip?
The trigger is that combination of the priming we talked about and the frequency strength. Your brain is unconsciously choosing which set of frequencies to pay attention to. If the high-frequency parts that signal Yanny are strong enough to get through your ear, say you have younger ears or good headphones, your brain might just choose to focus on that sharper profile.
And if those high frequencies are weak or filtered out by your ear,
the brain defaults to the strongest available signal. In that case, the lower, more sustained energy of the Laurel sounds.
So the brain is actively, though we don't know it, making a choice between two competing data streams. All these layers, the priming, the acoustic overlap, the frequency loss, and this final selective attention, it all came together to create this massive worldwide argument.
It's a perfect storm of perception science. It really is.
So after this whole deep dive, I think it's time for the big reveal. We have to settle the score for our listeners. So what does it all mean? Which word was it originally?
Okay, so based on the definitive source material, if you heard Laurel, you are technically, objectively correct.
Yeah.
The original word being spoken in that recording was, in fact, Laurel.
So the 53% are validated, but then why did almost half of all listeners hear something that wasn't actually the original word? The mystery of the Yanny sound is still there.
Because the ambiguity wasn't an accident. It seems it was engineered. The whole reason this conflict exists is that the original Laurel recording wasn't clean. It was recorded in a way that had these very specific, higher frequency components overlaid on the original sound.
Wait, what?
Essentially, they put the data needed to build the word Yanny right on top of the actual word Laurel.
So it wasn't a glitch, but an intentional overlap that basically exploited natural human variation in hearing. They created an auditory illusion by layering one word's frequency profile over the other one.
That's the key takeaway. Your perception is shaped by this whole cascade of factors. The external suggestion of the words, that's the priming. The physical overlap of the sound waves, and the physical capacity of your ears. And finally, your brain's selective focus on one part of a complex sound over another.
It certainly makes you think differently about how we process the world around us.
If we connect this to the bigger picture, the core insight here is that objective data, a factual recording of the word Laurel, can be intentionally altered. It can be changed through subtle engineering, like overlaying high frequencies, to exploit our biological differences and our cognitive biases. This creates a subjective reality for half the listeners that feels just as compelling, even though only one reality is technically correct.
Which brings us to a final provocative question for you, the listener. If a subtle change in frequency or context can cause a nearly clean 50-50 split over a 4-second audio clip, what other things that seem definitively true are actually illusions? Illusions created by a specific context or by subtle alterations our brains are constantly being forced to reconcile. Maybe be a little skeptical of any simple experience that causes such a clean and fierce divide.